All right, so let's look at map number 2. And this is a little tricky one where we have to look at some of the features here. And one thing I see right away on this map is I see that the contour lines here are showing that a stream is flowing down in this direction here. You can see the rule of V, so the stream is flowing this way. But I also see when the geologic contact crosses that stream valley, that the contact points in the direction it dips. So these strata are striking in this direction and dipping back in that direction. And it looks like at a pretty shallow dip, because remember, the more exposure you see in the V's, the shallower the dip, right? So it's almost probably 10 to 15. In fact, they even have something right here. It looks like about 18 degrees. Yeah, so about 18-degree dip. So you can see that they're showing that strike going this way and dip. And also I want you to note that when they draw the strike line, I'll kind of copy this one here, the strike is usually, well, not usually, always parallel to the depositional contact. Then it's dipping back in this direction here. So there's strike and dip. You can see this one as well, strike and dip. In this case, it's dipping at about 14 degrees there. All right, so what are some of the questions they're asking us for this map here in I think this is in Montana. So what is the oldest geological unit present? Describe the type of rock and when it was deposited. Be sure to include your reasoning. So when we're looking at this map here, I'm looking at the column here. So this one is in better shape in that they do have the stratigraphy in correct order, with the oldest units on the bottom, youngest units on the top. So the oldest would be this Lion Sandstone, and it's lower Permian. So that's what you want to put in here, Lion Sandstone. And you can put SS for sandstone, and we'll say it's early Permian. So the last period of the Paleozoic. And describe the type of rock. So we said it's sandstone, Permian, and well, in fact, let's look, what other reasoning can we put on there? So that'd be this unit over here, and they called it P, looks like PY. So let's put PY over here, just to make it big. And the reason is, also I see that based on this whole packet of rocks, everything seems to be striking this way and dipping back that way, at least for these older units here. The quaternary stuff is cover that's kind of flat on top of that. But all this older stuff is striking this way and dipping back that way. So this rock, if you think about a layer stacking, this is at the bottom, and then these younger units are on top, and they're all dipping off toward the southeast. So we want to say that it forms what we call a monocline. So if we were to look at this in cross section, we would see a stack of rocks that looks like this. They're all tilting to, and this would be that southeast direction, right? So that would be this dip toward the southeast going in that direction. And then the older, this PY, would be down here. And younger, in fact, the youngest thing here would be the Cretaceous, this plain view sandstone. And then obviously quaternity is the youngest thing, but we don't worry about that. That's just cover at the very top. But we want to put this guy, plain view sandstone member, so it's lower Cretaceous. So I can't, so I'll put KSDF, it looks like. And so that would be the strata that we see there. So that's another reason that this Permian Lions Formation is going to be at the bottom. All right, so the next question, what does a dashed line in the northwestern corner of the map represent? How do you know? So on geologic maps, the dashed line usually represents either contacts that are not quite well defined, they're not sure about it, or a fault. But in this case, it looks like it's a fault. And one reason I can tell right here, if I zoom in to this part of the fault, I see that there's a little bit of offset right here. See how this member comes in here, and then it comes off over here. So there's a little bit of offset. So it looks like it could even be a strike slip fault that's showing some sort of offset like that, side by side. So we'll say it's and then when it's dashed, it means that it's tentatively located. It's not exactly there. It could be a little bit of this way or that way. And then the dotted lines means that there's a fault there, but it's concealed under younger rock. So in other words, this fault is older than quaternary, right? So obviously it happened during the Mesozoic time. And so younger cover is concealing it right there. So let's say here for that question that we're going to say it's a fault. and we'll say approximate location. And that's because of the dashed line. All right, so that answers that question. Then the next question is, what does the pink line in the northeastern corner, in fact, it's really the more the south of the map represent? And so there's a problem here. It's not really the southeastern. It's more this right here, this pink line. And I can see, and I'll make these arrows bigger, this represents two arrows pointing at an axial plane. So this line is an axial plane. So it's some sort of, and since the two arrows is going to be a syncline. So we have some sort of fold there, a syncline. So let's put that over here. So that's the axial plane. But based on what I saw there, it's probably a symmetrical. In other words, there's no plunge on that. So I don't see any arrows. So there's no plunge on that syncline. All right, so the next question is, how does the topography affect the outcrop pattern exposed in the Morrison Formation? So that Morrison Formation would be the this formation here. Yeah, this one here that has this very long V here. So remember I said that the longer the V for geologic maps, whenever they cross a stream here, the shallower the dip. So let's say here is at so Morrison relative to the Plainview sandstone member. So let's look at the Plainview sandstone member. So Plainview sandstone member would be this unit here, right? Oh, yeah, and I can see that there's some, so this would be that syncline in here. So it looks like the dip of the Morrison Formation is very shallow. Oh, and then here's a clue right here. Look at this symbol right here. This symbol with a bullseye, I'll make it bigger here, means that the strata is horizontal, right? So there is a difference right there. So we'll say that the Morrison Formation, FM for abbreviation, has a shallow dip. And that's going to be our rule of V for geologic maps, right? Remember, that's different than the rule of V for topographic maps. And then the Plainview, horizontal dip, right? So there's a difference right there. Are there any conformities on this map? Yeah, there's an obvious one right here. So this is a major conformity right here. In fact, you're missing the entire Paleogene and the Neogene, right? So we'll say yes there. Could there be any other ones? So we got lower Permian, upper Permian, Triassic. So what's this? This is lower Triassic, upper Triassic. Then we have Jurassic, it says upper Jurassic here. And then we have the lower Cretaceous. So if anything, I mean, we're probably splicing hairs here. There could be, see, we're missing the lower Jurassic right here. So if this geologic map is mapping the strata in this much detail, if we go from lower to upper, low, then we're probably missing something right here. So where is the lower Jurassic question mark here? And so maybe this would be a disconformity. So there's two things going on. There's this disconformity and the fact that, remember, the Quaternary strata is all going to be horizontal as well. And the fact that all these strata older than Quaternary are dipping, so this one's probably an angular unconformity. So that's what we want to add here. So there's two unconformities that we'll talk about. So there's the lower Jurassic disconformity, and then there's the angular, say before Quaternary. So before the Quaternary. So anyways, I hope that helps. Again, I had some problems with these maps. They just weren't done correctly, and I'm going to change these for next semester. All right, we'll see you guys online next time.